Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am the teacher, Bronwyn Slate. If you'd like to participate live, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You're always welcome to join me live through the Zoom link, which is available both for me, your teacher, and also your DEC. Our classes are scheduled Monday through Thursday from 10 until 11 in the morning, and we are in our 4th week of our 9-week course. So what work should you be submitting for marking at this point? Well, the support questions, the ones with the little pencil icon, are not for marking. These ones are practice problems, and you decide which ones and how many to do. If you're understanding a concept, feel free to skip any questions. You don't have to do them all just because they're there. You know what you need to do. The answers are in the back, so please check your work, as this helps you know if you're on the right track or if you're still struggling with a concept. The key questions, however, are the ones to submit for marking. So please do all of these questions, showing all of your work, your steps, and your thinking. This way I understand what it is that you understand. And if you're struggling with anything, then I have more information about how to support you. So how do you submit your work for marking? Well, you can scan and send your work electronically. If you have a smart device, you can scan your completed work using that device. Apple devices come with Notes app that has a scan function, and Android devices have a Google Drive app that has a scan function. They're fairly straightforward pointing and clicking, but if you need some support, I have tech tutorials on my YouTube channel that will walk you through how to actually scan using these apps. If you need more support, let me know and I'm happy to help. Then you can also send them by either email or Facebook. You can email it to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca, or you can send it to me through Facebook Messenger, where my name is B Slate Wahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street. We are the bright red building next to the post office, and we have a small white mailbox next to our side entrance. So you can just put your work in there at any time. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students can also fax in their work. Just let us know that you're sending it, as things can sometimes get lost in the shuffle. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B Slate Wahsa. So all of our radio Zoom classes are recorded, and I upload them to YouTube shortly after broadcasting. So they can be found there, and I link them into my Facebook. We have a playlist called MBF3C, which has all of our previous lessons as well as some other resources there to check out. These resources are short videos that explain common errors and confusing concepts. So it's a really good place to go and touch base if you need some extra support and I'm not available. Math is a really visual subject, so I strongly encourage you to access the videos. If you can't join me live through Zoom, you don't have to talk to me if you can, but if that doesn't work for you and you can't access the YouTube channel, then let me know and I'm happy to send you a copy of the videos so you still get the full experience. So if you have any questions or concerns, please reach out and connect with me. You can email me at bronwyn.slate@nnec.on.ca. You can send me a Facebook message at bslatewahsa. Call me at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., but I teach from 9 until 11, so that is not a good time to try to get a hold of me. Today is a Throwback Thursday lesson, so we're going to be focusing a little bit heavier on lessons 5 through 9, but we are going to be reviewing all the way back to lesson 1. So you may be asking yourself, why are we reviewing already? There's been studies done that show that we forget information quite quickly. So research done by Herman Ebbinghaus in 1885 showed us that within one day, we've only retained 80% of what we learned the previous day. Then as that continues, by 3 days, we're now down to less than 60% that we've retained. And by 70 days, we're down to less than 40% that we've retained. So a week, and we've only retained about 40% of information that we've learned. So this is why we need to review frequently, because as we review, we remember, we understand things more deeply, and we top up our understanding back up to 100%. But that also means that we don't forget things as quickly. So our retention is longer if we review things more frequently. So it means that by the end of the course, if we reviewed more frequently, you haven't completely forgot everything in lesson one. I know in my experience, going through a course, a semester or a term, and getting to the end and feeling like I have to relearn everything that I did at the beginning of the year or the beginning of the semester, because it just seems so far away and I have no recollection of what we did. That's because our brains don't store information in that way. So if we continue to spiral back and review, we're more likely to remember things for the longer period of time and actually retain and hold on to that information. But before we go back and review what we've done so far, let's activate our brain with some mental math. As you know, I don't believe in mad math minutes. They cause stress and anxiety in students and don't generally teach them anything. We focus on speed and memorization, but instead we focus on understanding concepts and making connections so that you can use friendly numbers and strategies that work for you as an individual. Our question today is 374, take away 86. And we're going to be using the strategy of counting back in groups. So I like to use an open number line when I do this sort of visualization. So what we're going to do is we're going to start at the far right with 374. That's how much we have in total. And we want to take away 86 things. And we're going to do this in friendly chunks. So we're going to go back first. And because it's an open number line, it doesn't matter. You don't need to be exact, precise. So that was right. We're going to subtract 4 first and end up at 370 because that's a friendlier number. Now I want to subtract 86 in total, and I've only subtracted 4. So I need to keep going. So I'm going to subtract in a couple of jumps. I'm going to maybe subtract by 20s. So if I go back 20, then I'm now at 350. And this is the part that you can do whatever feels comfortable for you. Subtract another 20. So I'm at 330. I'm going to subtract another 20. And I'm at 310. As you can see, my arrows are not equal. They're not to scale, but that's fine. It's okay. So now I need to subtract another 20, but I'm not quite exactly sure what that's going to look like. So I'm going to subtract just 10 first to get to 300. And because I've subtracted 20, 40, 60, 70, I need to subtract another 10. And now I'm at 290. And that was a little bit easier for me to do. So now I subtracted 10, 20, 40, 60, 84, but I need to subtract 86. So I'm going to subtract another 2, and I get to 288. So counting back in groups, you can count back in whatever groups that are friendly for you, and that can get you to where you need to go. So 374, take away 86 is 288. All right, so before we do some mixed practice, let's highlight what we've learned so far this term. So first, to cover unit 1. So lesson 1 was transformations of quadratics. Remember, we used the formula y equals a times x minus h to the exponent 2 plus k. And then we looked at those variables and how they shift the parent function to make all the different quadratics that are possible. So a tells us the opening direction. So if it's positive, we're open up. If it's negative, we're opening down. It also, remember, does that stretch. So are we getting narrower or wider? We don't look too closely in that in this course, but that does what A tells us. H tells us the horizontal shift. So are we moving the whole parabola to the right or to the left? And this one is tricky because H is not, because we are subtracting H here, then our H value is actually the opposite of what it looks like in our equation. This doesn't, if you don't remember this, or you didn't actually look at this lesson, go back to the videos on lesson 1 and look at that in more detail, and you can figure out why that happens. K is our vertical shift, so shifts our whole parabola up or down, depending on if K is positive or negative. Lesson 2 was polynomials and factoring. So we remember that expanding means to multiply according to the distributive law. So we had a whole bunch of different options in terms of using FOIL or using algebra tiles or using the box method to help you remember to multiply all the parts to all the parts. And then factoring is doing the opposite. So it's finding the two binomials that result in the trinomial product. So, and we looked at using algebra tiles or using other, just using a number method to figure that out. In lesson 3 was solving and graphing quadratics. So solving a quadratic means that we're asking what values of x result in y equaling 0. So what are the zeros or the x-intercepts? Another way of saying it. And we needed to sometimes use factoring in order to figure that out. Then lesson 4 was the exponent laws. And there were a whole bunch. Remember, this was also 2 videos if you need to go back and look at them again. So the rules are that multiplication, if you're multiplying 2 numbers or 2 powers with the same base, then you add the exponents. If you're dividing 2 powers with the same base, you subtract the exponents. If you're doing a power of a power, then you multiply those exponents. If you have a 0 exponent, your answer always equals 1, doesn't matter what the base is. If you have a negative exponent, the reciprocal of your, so that means is equal to the reciprocal of your base with a positive exponent. Those last 2 are kind of tricky and a little bit weird. Most people have a hard time wrapping their heads around that. So if you need some more practice, go back again to those lessons and look at them, or feel free to reach out and we can talk them through some more. All right, so then lesson 5 was solving exponential equations. So here we looked at the parent function of an exponential, which is y equals a times b to the exponent x. So b is our base, and that can be any positive number except for 1. And a is our scalar, and it can be any non-zero number. So if b is greater than 1, that means that we have exponential growth. So our graph goes from small y values, the smaller our x values are. And then as our x values increase, our y value also increase really, really quickly. If our base is between 0 and 1, we have exponential decay. So if it's a fraction or a decimal, that means that we're starting with really, really high values of y. And then as x increases, our y decreases really quickly. If a is equal to 1, then all of our exponential graphs are going to go through the point 0, 1, because when x is equal to 0, then our b to the exponent of x is equal to 1. And so if we multiply it by 1, that means that it's always going to go through that point on the axis. And we remember that with exponential equations, we do not have an x-intercept. Y never equals 0, as long as we're not, if we shift our equation, we could, but that it has a different asymptote, it has a different place that it never hits. So for the base understanding, we never cross that x-axis. Okay, lesson 6. So this is moving on to unit 2. We looked at simple interest and linear growth. So simple interest, remember, is both an arithmetic sequence and also linear growth. So this is because the pattern increases or decreases at a constant rate. We're adding or subtracting the same thing over and over again. And so this means that our interest moves in a straight line. Our formula is I equals PRT, with I being the interest that we've earned, P being our principal amount, R is our interest rate, and it's a percent, but we have to express it as a decimal. T is our time, and our time has to be in years. And then also to find our A, our total, our final amount, we have to do our principal plus our interest. Then in lesson 7, we looked at compound interest and exponential growth. So compound interest grows exponentially. So the pattern increases or decreases at a constant ratio. We're multiplying or dividing by the same amount each time. Our formula is A equals P times 1 plus R divided by N, all to the exponent NT. Remember, where A is still our final amount, P is our principal, R is our interest rate, again, as a decimal. T is our time, again, in years, but N is our number of compounding periods. So how often we reinvest and start making interest on that interest that we've already earned. And then to figure out the actual amount of interest, we need to do our amount, take away our principal to find the actual amount of interest that we've earned or need to pay. All right, lesson 8, we then dove a little bit deeper into the compound interest formula. So we tried to dissect the compound interest problem because we had to figure out that it must say compound in the problem in order for us to know that we are dealing with compound interest. We must identify what information is given in the question and therefore what information we're being asked to find. And that is tricky, but it's essential in order to understand, in order to actually get through these problems. If we were finding the principal, we need to rearrange our formula using algebra to isolate for P. If we're finding the interest rate, we need to use the nth root to isolate for R. And if we're finding the time length, we need to guess and check to force the bases to be the same. And then the exponents can be set as equal in order to isolate for T. So these are tricky and a little bit weird. Again, if you don't remember them or you need more practice, you're not feeling super confident, go back to those videos, look at those support questions. If you need more practice, let me know and I'm happy to send you more or we can talk about it in order to really understand how these work. And then lesson 9 was looking at loans and RSPs. So loans are when you borrow money that is paid back through equal payments over a set period of time, including the interest that you're going to pay back. Payments are calculated according to how much we want to borrow or how much we can borrow is calculated according to the payment we can afford. RSPs are a saving plan with people who earn income. It pays regular payments once you retire, and we realize that investing in the long run is better because it means that we get more money overall. All right, so that is what we have covered so far in in this course. So we've gone lessons 1 through 9. So we're almost halfway through the course material. So we're going to do some mixed practice, which is when we don't know which question is attached to which lesson, so that we can figure out what it is what tools we need in order to actually solve these questions. Okay, so number 1, Janet borrowed $2,300 at 10% per year compounded quarterly. How much must she repay after 5 years? So remember at the end of the RSP, lesson 9, the loans and RSP lesson, there was a chart that talked about how do you know which question to do. So I strongly encourage you to go back and look at that, or as I said, take screenshots, write it down so you can help figure out how you know based on the question which tools you need to use. So with this question, it says that it's compounded. So we know that it's not simple interest because it's a compound question. And we're saying that we're repaying the whole loan back after 5 years. So we are not making payments. We are just paying it all back at once. So that makes me, that tells me that we are in a compound interest question. Okay, so now how do we actually answer the question? Question A, how much must she repay after 5 years? So because we know that it's a compound interest question, we know that our formula is A equals P times 1 plus R divided by N to the exponent N T. So A is what we're looking for. How much she's going to have to pay back. Our principal P is 2,300. Our rate is 10%, so 0.10. Our N, it's compounded quarterly, so that means that our N is 4, and our T, how many years, is 5. So now that we have our variables, we put them all, we substitute them in. So 2,300 times 1 plus 0.10 divided by 4, all to the exponent 4 times 5 equals. So, and as always, you can decide if you want to do this in parts or do this all at once. I will continue to do it all at once as it saves time so that we have more time to do more questions. Oops, forget that I have to put the exponent in brackets or else it won't let me multiply my exponents. Okay, so I get $3,768.82. Okay. So then how much of the amount that she pays is interest? So we're trying to figure out how much is the interest. So that means that to find the interest, we have to do our amount, take away our principal. So our amount is $3,768.82. Take away $2,300. So that is going to be $1,468.82 is what it is in interest. And that's how you do a compound interest question. All right, next, number 2. In a target game at Dryden Fair, players launch a beanbag toward a bucket using a mallet and a small seesaw. The path of a beanbag that lands directly in the bucket can be modeled by the relation H equals negative 0.65 d squared plus 1.625 d, where H is the beanbag's height above the table and d is the beanbag's distance from the seesaw, both in meters. How far is the beanbag from the bucket at the start? So this is why we do some practice and we go back to the beginning, because this is like, what? We haven't been talking about this at all. So how I know that this is a quadratic equation question, solving quadratics question, is because I have H equals negative 0.65 d squared plus 1.625 d. So I have this squared. My order of my equation is 2. So I know that I'm dealing with a quadratic. And so I'm trying to solve, I'm not just factoring, I'm just trying to solve information about this. So that's how I know that this is a solving quadratics question. So I know what kind of question it is. That doesn't mean that I totally haven't figured out what I need to do yet, but I know that I'm talking about those parabola shapes. So with this type of question, I think it's always important to draw a picture. I am not an amazing artist. I'm actually pretty crappy, but this helps me visualize what it is that we're talking about. So I'm going to start with a little seesaw and my beanbag. Okay. And I know that I'm shooting that up and it's going to come down and hopefully land in a bucket. So as we can see, this is the shape that we're talking about. And we're trying to figure out how far is the distance between the bucket and the start, where the beanbag starts. So I could think, well, I want to find the distance between the 2 points, or what do I think? But I could also be like, wait a second. I want at the time that my beanbag is, wait a second, I'm trying to think. That'll tell me how far is the beanbag from the bucket at the start. So I need to figure out I wanted to say, well, I need to figure out where it is when the beanbag hits the ground again, because that is where the bucket is, right? It's on the ground. So that means that when my height is 0, right? So that's how far, when my height is 0, I'm going to figure out the two distances. It should be 0 to start with. My distance from the seesaw should be 0. And then my other distance will be how far the bucket is, assuming that I landed directly into the bucket. So if h equals 0 is when it's in the bucket. So I have 0 equals negative 0.65 d squared plus 1.625 d. Okay, so we have it set to 0. That's great. Now we need to figure out, can I factor this negative 0.65 d squared plus 1.625 d? Now it is not friendly numbers that I'm like, know what I want to factor. So what I'm going to check to see is if I can factor out negative 0.65, what happens if I divide 1.625 by negative 0.65? What do I get? So it would be great if I typed the right number. I get negative 2.5. So when we have decimals, we can still factor them out to potentially get friendlier numbers, even if they're not whole numbers. So I'm going to factor negative 0.65 d out. And that means I end up with d minus 2.5. So remember when we were talking about quadratics, what this means is that either, because I have two numbers that are multiplying by each other and they equal 0, that means that either negative 0.65 d has to equal 0, or d minus 2.5 has to equal 0. Those are my only options. So, well, if negative 0.65 times d equals 0, that means d has to equal 0. The only way for this to multiply by another number to get 0 would be if d equals 0. And here, d minus 2.5 is equal to 0. That means the d has to equal positive 2.5 in order for it to equal 0. So to answer our question, how far is the beanbag from the bucket at the start? Well, it doesn't make sense that our distance is 0, because our bucket isn't right next to our beanbag. That's where our beanbag is starting at ground 0. So that means that our bucket is these other options. Our bucket is 2.5 meters away from the beanbag. And there we go. We figured it out. So this again is why it's really important to go back and practice, because I had to think a little bit hard to remember what it is that we've learned way back when. All right, part 2 or part B. How high would the best shot be to land in the bucket? Sketch the pathway if the beanbag reached a maximum height of 2 meters and at 0.5 meters. So I've got the part of information that shows us our zeros from part A. I've hauled that on so you don't have to remember it. I've written that down again. And we want to sketch the pathway with the beanbag reached maximum height, 2 meters and 0.5 meters. So I'm going to draw myself a sketch. So I'm going to draw myself an axis, which I didn't draw last time. So this is a little bit different. Now we're using more math opposed to visualizing the actual thing that's happening. So remember, we know that a perfect shot goes up, starts at 0, and lands at 2.5. That's a perfect shot, right? Because that's what we just calculated, that it hit the ground at 2.5 meters. So that's where the bucket is. Okay, and we're wondering, what is our maximum height? What is that number going to be? So, but it's also asking us to sketch it if our maximum height was 2 or if our maximum height was 0.5. So what we can do is, if our, I'm just trying to think about how I do this. So we know that our maximum height is going to happen halfway between our two zeros. So halfway between 0 and 1.5, sorry, 2.5 is 1.25. So we're wondering, when our distance is 1.25, what is our height? That's what we're wondering here. So we're going to put into our equation, h is equal to negative 0.65 d squared plus 1.625 d. So we want to know that when our distance is 1.5, what is our height? So we're just going to substitute 1.25 into our d. And then see what that height is equal to. So again, we're going to use our calculator. Slide it out of our way. So we have negative 0.65 times 1.25 squared plus 1.625 times 1.25. So that, just making sure that I put in all the right numbers. Yep. Okay, so that's 1.02. So that means that this height here that we're wondering is 1.02 meters. So that is the best shot, would be landing at 1.20 meters. So then to sketch our other ones, we can say, well, if it reached a maximum height of 2, so that means that if it went all the way up there, then it's going to land all the way down there. So that's going to be way overshot. And if we make a shot that only goes as high as 0.5, we're not going to get it into the bucket. And so that's the second part, is sketching the pathway of the beanbag if it reaches a maximum height of 2 meters. So we shoot way too high, so we're going to be way too far. Or if we only shoot half a meter and then we are too short, we don't make it all the way to the bucket. And because our sketches were just rough approximations, is totally fine. Okay. Number 3, the population of the Kenora District P, we're going to call it, is projected to grow until 2050 based on the relationship P equals 65,533 times 1.029 to the exponent n, where n is the number of years after 2016. Okay, so what type of question is this? This is an exponential question because we have our equation here and we have our variable in our exponent. So it's exponential equation. Okay. So that's good to know, good to start. Now we need to sketch a graph of this relation. So I'm just going to put in, I've done this to be more precise. I've done this on using Desmos. So you can use Desmos as a starting place and then either print it or draw it out. But if we're sketching this graph, so we have our time in years after 2016. That's when, so 0 here is really the year 2016. And then every year after that is a year after 2016. That's how it's defined in our question. And then our population shows us how fast it grows of people after those years. So this is how we would sketch that. Again, because we're using such big numbers, it's a really good idea to use technology to sketch this because it's going to be really hard to get it really precise and then use that to analyze which are our next questions. So I strongly encourage you to use technology, which if you need help with, let me know and I'm happy to help you do that with Desmos. So part B, what is the p-intercept? So remember our p is our population. So this is our p-intercept, whereas this is our n-axis. So our p-intercept happens here. Where does our line cross p? So it happens there. And what is that amount? Well, if we think about that, that's when n is equal to 0. So that means that here we make that 0, which makes this whole thing 1. So it's just going to be 65,533 is going to be what our p-intercept is. And what does that represent? Well, that represents the population in 2016. At the beginning of this analysis. That's year 0. Okay, part C. What is the projected population in the Kenora district in 2032? So first we need to think about, well, 2032, that's 16 years after 2016. So we're going to go over to 16 years, and then we're going to think up to here, and then we go from where we hit it over here. Again, this is really hard to do with my very inaccurate smartboard pen, but we're doing a rough approximation. So if this is 100,000 and this is 150,000, so this is 110, 120, 130, 140. So I'm going to say that looking at where it is here, it's maybe like at 104,000. Again, if you were to give me a slightly different number, that's okay. I'm just looking for something around that range. So that's how many people is projected to be in the year 2032. And then what is the projected population in the Kenora district in the year 2047? So again, we need to remember that this is 21 years later after 2016. Actually, that's not true. That's 31 years later. My bad. So 31 years, we go here and we go up to our graph, and that looks pretty close to that line. So then I'm just going to come across here and say, well, that's about 160,000 people is the projected population in that year. And that is how we do it. How do we analyze graph? All right, number 4, the stopping distance of a particular car can be modeled by the relation d equals 0.006 s squared, where d is the distance in meters and s is the speed in kilometers per hour. The speed limit on in-town roads is 50 kilometers per hour, while the speed limit on highways is 100 kilometers an hour. How much extra stopping distance do you need when driving 10 kilometers an hour over the speed limit? Compare both in-town and highway situations. So again, this is another quadratic equation because we have this, our exponent is a 2. Okay. And with this, we're going to graph it to help us understand what we're talking about. So I've graphed it again with Desmos to help us get exact information. And I've labeled what it is that we're talking about to help us understand. So we have this red line is d equals 0.006 s squared. And the blue line is 0.006 s plus 10 squared. So this is actually kind of like a quadratic transformation question from like lesson 1, because we're looking at, we've changed our h value. Here our h value is 0. Here our h value is now -10. And so that shifted our parabola. So let's go back to what the question's asking, because it was a lot. How much extra stopping distance do you need when driving 10 kilometers over the speed limit? Compare both the town and highway situations. So in town, we're driving at a maximum of 50 kilometers an hour, right? So that means that this is what we're talking about. So if we're driving 50 kilometers an hour in town, it's going to take us, so this is our distance in meters is our y-axis. And so we're at 10, 12, 14, 16, 18, 20, just making sure I have the right scale that I'm expecting. So this is about, it's going to take us about 15 meters to stop if we're driving at 50 kilometers an hour. But then if we compare that to if our other graph, which is when we shift it up we're shifting it over, and now we're at 50 plus 10 is going to be 60. So this one, even though we're comparing it to 10 kilometers faster there. So that means that here, now it's going to take us like almost 22 meters to stop. So only driving that 10 kilometers faster, which many people do, it's going to take a whole another 7 meters to stop, which is like probably, I don't know, almost 2 car lengths. I don't know. Like that's a significant distance if you're stopping for like safety reasons. Then at 100 kilometers an hour. So again, we're going to go look up to where our graph hits. Sorry, it's really hard to draw a straight line with a smart board. So our 100 kilometers is like here. Again, really bad to draw a straight line. Let's try it one more time. Okay, so at 100 kilometers, it takes 60 meters to stop. But if we drive just 10 kilometers more than 100 kilometers, so 110, now it's taking us over like 75 meters to stop. So now it's 15 meters longer to stop when we're driving on the highway. So this is why that's how much stopping distance, that's how much planning you need to make in order to know when you're going to stop, depending on the speed that you're driving. All right, number 5, a paycheck advance company will give you money for your paycheck 2 weeks before you receive it. They will pay you your paycheck less 10%. For a paycheck, how much money would you receive? So we are doing, this is going to be like a simple interest question. Oh no, let's think. No, we're not calculating interest. This is like a commission sort of. No, simple interest. Sorry, I just couldn't remember what class I was in. So for a paycheck of $1,200, how much money would you receive? So we're going to do 1,200 times, well, we are losing 10%. So we're going to times it by 0.01. And that's happening once. And so that's going to be $120 is how much we're going to lose. So that means that we would receive 1,200, take away 120, which is $1,080 is how much you would actually receive. Okay, so then part B, what annual interest rate, compounded weekly, would you be paying on this loan? So this is a compound interest question because it says compounded weekly. Sorry, my writing is bad up there. Okay, and I've already collected all of my variables. So I'm trying to figure out the rate that's what we're trying to learn about. So we know our formula is A equals P times 1 plus R over N to the exponent NT. And we know that our original amount was 1,200. Our principal, how much we actually got, was 1,080. Our rate is what we're looking for. We're compounding it weekly. So we're dividing it by 52. And our time period is, because these payday loans are like 2 weeks. They said that you're going to pay it back in 2 weeks. So it's 52 times 2 times divided by 52. So then in order to find our R, we're going to have to do 1,200 divided by 1,080 equals 1 plus R to the exponent 52, R divided by 52, the exponent 2, because 52 times 2 divided by 52 is 2. So then 1,200 divided by 1,080 is equal to 1.11. And we need to take the square root of both sides in order to figure out to get rid of that squared. So we end up with 1.054 is equal to 1 plus R divided by 52. So then we subtract 1 from both sides and we get 0.054 is equal to R over 52. Sorry, when it's low, I write messily. I apologize. So I'm going to write that one out again. R divided by 52. So that means that we're going to multiply both sides by 52 in order to get our R by itself. And that's 2.81. Remember, we haven't turned it into a percent yet. So that's 281% is equal to R. So the interest rate that you would be paying is 281%, which is like super, super high. All right, so we run out of time to do these last couple of questions, but now we have reviewed lessons 1 through 8, so you can submit those for marking and let me know if you have any questions. You can give me a call at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. Send me an email at bronwyn.slate@nnec.on.ca, or connect with me through Facebook at B-Slate Wahsa. Remember, this lesson, all of our other lessons are up on YouTube under my channel, B-Slate Wahsa, and we have a playlist called MBF3C where you can find all of our lessons there. Thank you so much for joining me today. I hope you have a lovely day. Miigwech.